Hi there. Today I'm going to explain you something regarding simple harmonic motion. Okay, in this one I will include some of the definitions according to the question. This definition is already given. This is an example. So and answer, and I'm going to just describe few theory related questions. After that, some of the mathematical questions as well. I will show you like a trailer of a movie. See this one and you will find something. See, in this one I'm going to show you something relationship between the degree and radian. I'm going to show and new one, some theoretical questions, all the theoretical relationship and the mathematical expressions all going to obtain here. And there are some other videos, so questions. Then now you will say some of the mathematical applications as well, and you to apply how to apply. And in the very next one is also definitions and obtaining the equations expressions for the displacement equation in simple harmonic motion, and some of the mathematical calculations here. And there are some two calculations. This one is a little bit tough one, another one. So these ones are the ones you will see. If you want to know any of these questions how to solve, just watch the video and get something from the video. Okay, let's start the video now. Okay, now I'm going to start the questions. Define radian and write down the difference between the radian and degree. The angle made at the center of the circle by an arc whose length is equals to the radius of the circle. How to do it? Now have a good look at the radius. This one is the radius and the radius, all same in the same similar color given. And the arc length. See the arc length. In this one, for one different definition of the degree thingy, so you say the arc length that is equals to the radius. If you start the arc from here, if we say this point as A and this one as B, from A to B the arc length is exactly equals to the radius. If you have any of this type of arc, the subtended angle is nothing other than 1 degree radian. Its value is somewhere around 57 degree. Okay, now the arc length and the radius given in respective colors, you can see it. Now I will show you the difference between what I will just explain it verbally. So the difference between the radius and the degree is nothing other than, see, so here this one you may say, you can see it now. Have a good look at. It start to move from here. If you see the difference now, see, now start to move from here. Now I'm going to start right from the beginning. If you're starting from this point, you can see how the angle changes. This is the degree values. You can see the starting of the degree values even. See, now it says the degree value increases and comes to some value of what, 360, and stops there. So that's how. But in this case, in this particular case of the radian, so you measure length, not the angle you tilted. You keep measuring the distance, right? Ratio of two distances, that is the difference. Understand, this is just if you just turn your head, the angle of turning head is the thingy. But in this guy, you are just measuring the length over the radius. That is how you measure the angle difference between the radian and the degree. Okay, now let's move for the next question. Define the angular velocity. What is the angular velocity definition? The rate of change of what? Rate of change of what? The rate of change of angular displacement. That is the definition for what? Angular velocity. Obtain an equation for the relationship between angular velocity and tangential velocity. So if you consider this radius, this particular radius, and an object which is in a motion, angular motion of omega, so how to obtain? So we know one thing. What? Speed v is equals to distance divided by time, and we know that distance is nothing other than, so there is the equation here. If you get the symbol wise equation, theta is equals to s over r So the S is equals to r theta. Now I'm going to substitute that equation to here. You may see now what happens. V is equals to r theta over t. This looks really ugly now. I want to rearrange. What do? Is I just write in this way, theta over t. What is theta over t? Theta over t is nothing other than, as you know here, the omega, angular velocity, is according to this definition, rate of change of angular displacement. Angular displacement is delta theta is equals to what? Change of angle, and the delta t is the time. So simply we can take it like omega is equals to theta over t, and so we know that theta over t is nothing other than angular velocity. So the equation is going to be V is equals to r omega. Really simple option. Then you can use it and just keep practicing. Then you can be master of this part. Let me explain you the other part. Now I told you I'm just about to give you some definition about what radians and radius and radian and degree, relationship between radian and degree. So for a circle, it's really ugly circle, don't worry. Rather than consuming your time, I prefer using this method. So the circumference, what is the relationship between circumference and the radius? How to do it? C is equals to 2 pi r. Equation number 1. Now according to the previous equation, let me show you. In the previous one, I just obtained certain equation here. S equals to r theta. In this one, S is the arc length, any arc length. So for full completed circle, the S is nothing other than circumference. So S is equals to r theta. Now in this one, S is replaced by this one. So the equation becomes C is equals to r theta. Number 2. So you can just combine these two equations together and obtain something like this. What? R theta. So equation number 1 equals to equation number 2. In this case, r theta is equals to 2 pi r. And this r and r going to cancel off each other. For full circle, complete cycle, the angular displacement is 2 pi, value of 2 pi radian. Now you know for complete cycle. Now what is this theta value? In degrees, it is nothing other than 360 is equals to 2 pi radian. Okay. So if we can obtain many other results, let me show. For if you know that for 360, it is 2 pi. If we divide this by 2, both by 2, we can obtain something. If you divide this by 2, 180 is equals to pi. You can keep dividing. So now you can keep dividing. Now what can I do? Again divide by 2. 90 is equals to pi, just pi, and 45. Keep dividing. So 45 degree is equals to pi over what? 2. It is pi over 2. Sorry. I just made a mistake here. It is like just pi over here. So I made a big mistake. I just didn't see. So it's pi, and this is pi over 2. This one is becomes pi over 4. So one of the series now is all about 45, 90, and it's 45 series. Now let me get the 30 series. How to get it? So you know that if I divide this by, so this value by 6, what can I do? So 360 divided by 6. So your answer becomes what? 60 degree is equals to what? If you divide this by 6, that means pi over 3. The answer is 60 degree is pi over 3. So it is like pi over 3. Now for the next part, so it is like 30 degrees equals to what? Pi over 6. In the same way, so I can obtain many other like 120, it is equals to 360 divided by 3, that means it's like what? 2 pi over 3. These are the some of the results you may obtain. So you can keep obtaining many other results like of 15 degree and so on. So keep remember these values, not all, just this much of this more than enough. Okay, let me move to the other question. So this is an additional explanation. Now, the define periodic time of a muon and a particle object, which is a periodic circular motion in a circular path, then obtain a particle relationship between the angular velocity and periodic time. Okay, now muon is a particle. The spelling is a little bit wrong here. It's like a muon, so typing mistake. So the define a periodic time of a muon that object circular motion in a circular path. Is you don't want to worry about what is a muon. I just talk it. So it's like an electron-like particle. It's keep moving in a circular path and keeping reading. It's like imagine a sun and the earth. Earth is revolving around the sun, keep revolving. So imagine in that way. So it's simple. So, however, you have to obtain a circular path, obtain the relationship between angular velocity and the periodic time. Okay, let me explain you. So, actually, you don't want to worry about that, but I'll explain you. If you start from here, t equals to t0, and you finishes at the t is equal to time of t, capital T. How to obtain it now? If you just move in with a certain angular tangential velocity of v, if you are moving around that with a velocity of v, and the same way you are having an angular velocity of omega as well, we know one thing, v is equals to distance divided by time. Here we know the distance is 2 pi r over time. That's it, 2 pi r over time. So here, so we know one thing to do now. What is the 2 pi r over time? So you have to obtain the angular velocity thingy. So you know another thing. So how to get the angular velocity? V is equals to r omega. You are just now going to combine these two equations, equation number 1 and equation number 2. So equation number 2 is equals to 1. So here r omega is equals to 2 pi r over t. Somebody might just be wondering why it is t, because the time taken to complete one cycle is capital T, that means the periodic time. Okay, now r and r going to cancel off each other. Your answer is going to be, the relationship is omega is equals to 2 pi over capital T. Just remembering this equation is more than enough. If you have the skill to derive this one, it is an additional bonus result. So keep practicing. If you practice this for 1, 2 to 3 times, you can easily understand. There's nothing. Always try to get the concept behind it rather than just copywriting it. So okay, now define the rate of revolution and obtain an equation for angular velocity and the rate of oscillation. Define the rate of revolution and obtain an equation for angular velocity and the rate of oscillation. Rate of oscillation means the type of revolutions per making for time. It's like the frequency, how many revolutions you made per second. It's like a rev s minus 1 revolutions per second thingy. So what is the relationship? Angular velocity over time. It is like a defined angular revolution. Rate of revolution means the number of cycles per unit time. That's the definition. Number of revolutions per unit time. That's the definition. So how to get the equation? Obtain an equation for angular velocity and the rate of oscillation. So here this one, I'm going to rearrange this equation. 2 pi over 1 over capital T. What is 1 over capital T? We just know one thing. Frequency is equals to 1 over capital T. Now I can just write the equation in this manner. Omega is equals to 2 pi f. This is really essential equation you have to remember. Okay, now let's move to the other part. So explain periodic motion. So what is the periodic motion? So periodic motion means any repetitive motion just shown by an object to show what with a periodic time. It's like a motion of moon around the earth, earth around the sun, anything with repetitively time. So define simple harmonic motion. Before that, we should better watch the series of the video of the first one. So this is the equilibrium position, equilibrium extremes, two extremes, positive extreme and the negative extreme. So these are known as the amplitudes. An object may moving from this point to here and just moving between these 2 points. So the motion between motion of an object which is in acceleration, the acceleration is directly proportional to the extension, displacement, and it is always towards the center of the oscillation or the equilibrium position, or in other way you can define it in the other way around as well. The acceleration is directly proportional to the force as well, and it is towards the center of oscillation. It's a very long thing to write. That's why I'm not going to interested in writing, because in my previous video I've written all the things and explained very safely and very slowly. I took more than 10 minutes to explain this part even. So watch my previous video if you want to know something more. Now give an example for simple harmonic motion, anything. That means I've given those things even in the previous video at the beginning. So it's simple. So oscillation of a spring mass system is one of the example, and something like a certain this type of simple pendulum. So simple pendulum may just swing from back and forth, and a hacksaw blade, oscillation of a hacksaw blade, up and down oscillation, and a rubber ball which is immersed in a water, and if you just push it in, it will just begin to move up and down. These are good examples for what simple harmonic motion. Write the characteristics or equation of simple harmonic motion and give all the terms. This equation is something really extremely important. What is it? A is equals to minus omega square x. So in this one, I'm going to explain what is this A. A is the acceleration, and omega is the angular velocity, and x is the displacement. So it is like this. So from the equilibrium position, if an object moving with an acceleration, it has moved some distance of x, having the angular velocity of omega to the power square. This is a constant. If you find any constant thing, you have to use, and I'll show you how to use with this one with examples. Now for this one, explain how to use that equation to calculate with suitable example. Now I'm going to give you a suitable example here. A is equals to what? 16 pi squared minus 16 pi squared x. Oh my god, how to solve this now? Now our equation is what? Characteristic equation. In the previous one, this particular one. So now let me explain you. A is equals to negative omega squared x. You just need to compare. So have a good look at A is equals to minus omega square x. You have to show one thing here. A is proper resemblance to A in this equation. This whole set, apart from minus sign, 16 pi square is resemblance to omega to the power square, and x is equals to x. To find out something like a periodic time, how to find it out? Now you have to obtain, to find out the periodic time in the previous page, very previous one, you know there is something called omega is equals to 2 pi f. Also you can get this equation inverted, 2 pi over omega. So that's why I told you to have a good look at it with care. So how to get it? 2 pi over omega. So you don't know omega yet. So if you know omega, you can easily obtain what? Time. How to obtain omega now? From this one, I can write it like this way. How? Omega, not omega, omega square is equals to 16 pi square. So how to obtain omega? Get the square root of both sides. Now you may see it like this way. Omega is equals to 4 pi. Now let me apply this particular result to here and get the periodic time. So it's really simple. 2 pi over 4 pi. My answer is going to be what? Half, or another way, 0.5 seconds. Now I can use this knowledge to obtain the frequency. You know what frequency is equals to 1 over capital T. So it is nothing other than 1 over 0.5. That is what? 2 hertz. This is how you to use. Now I'll do these 4 questions. In this one, I'm going to obtain omega. Omega is what? Square root of this whole set, because it's like a resemblance thingy. Same resemblance. So omega square. So omega is equals to pi 5. 5 5, right? 25 root is 5 and 5 square root is 5. So the answer now I'm going to apply to this equation. Time is going to be what? Okay. So angular velocity I've already found, and the periodic time is going to be 2 pi over 5 pi. Pi and 5 cancel, so it is like periodic time is 0.4 watt seconds. So you may apply this to calculate the frequency. There is another way. What is the other way? The other way is nothing other than what? Omega is equals to 2 pi f, rather than this method. So frequency you can directly calculate in this manner. 2 pi over omega. What is my omega? So sorry, omega over 2 pi. I made a mistake. Omega over 2 pi. Omega is equals to 4 pi over my, sorry, yeah, omega is not 5 pi. Sorry, in the previous question it was 5 pi, 4 pi. So let me erase the whole set. So frequency is equals to omega over 2 pi. So omega is equals to 5 pi over 2 pi. So pi and 5 cancel. So frequency is equals to 2.5 hertz. Now I'm going to do the same thing for the next one. So you now know how to get the omega. I'm not going to explain. It is going to be square root of this one. 36 square is 6 and pi. So now how to get this result applied to here? The equation is 2 pi over omega. Omega value is here. What is 2 pi? 2 pi is still 2 pi. And omega is 6 pi. Now you get the answer like so, 1 over 3 seconds. This is how you to do. So keep practicing the other 2 questions by yourself. Okay, in the second question, it's mainly focusing on the displacement equation. How to get the displacement equation? Firstly, I have to show you one thing. So it's already drawn this one. So the radius of the circle is, in this case, the radius is equals to the A amplitude, because that's the maximum displacement it could move from here. So starting point to here, the finishing point. There's 2 different things from sine curve and cosine curve. If something starts at the respect to the y-axis, it's supposed to be the sine curve we obtain, and something from the x-axis to y. So that's the cosine curve. I will explain this in the previous video. If you are really new to this part, really complicated to understand, so watch that. It's clearly explained. So now there's no time to explain that again. So have a good look at. So this radius is nothing other than the amplitude, the maximum displacement. So it makes a certain, it starts to move from certain y-axis, top of the y-axis, to here, this point. So it has made certain angle, that is theta, respective to the y coordinate, y-axis. So have a good look at. Now the angle is theta. These 2 angles are just alternate angles, so the same similar values. The theta is here. Now I'm going to just draw the cycle only, but no problem. But I'll just draw something. So now that question is already done. Now let's go for the other one. And to make the relationship, okay, just before that, I'm going to go back to here and explain something. So according to this one, theta, and this is what? cosine of theta and x, the displacement it made relative to this point. If the point is at locating at this point now, it has made some displacement over here from according to the x-axis. That is what we want to find. Now I'll just mark it like x displacement, and the theta is here and it is 90 degree. If I consider this angle like PQR triangle, okay, now according to this PQR triangle, this is the hypotenuse. So how to get it? Just according to simple trigonometric ratios, sine theta is equals to opposite side over hypotenuse. So here what is the opposite side? It is sine theta is still sine theta, and the opposite side is x, and it is hypotenuse is a. So when you cross multiply, you can obtain the equation x is equals to a sine theta. This is the one of the basic equation you have to obtain, and I'll just give you an additional data. If you start from moving from here, it's going to be a y is equals to a cos theta. That is something you have to remember as well, but in this one I only mainly focusing on the sine theta component. Okay, in the next page, obtain an equation which includes distance, angular velocity, time and amplitude. Now my previous equation in the previous page, it is a sine theta. Now let me explain you. It is like what? Displacement is equals to a sine theta. So in the previous case, now it is x. So x is equals to a sine theta. From very previous results, very previous ones, let me show you. That's why I told you to remember these equations really carefully. Not here, not even here, this, not in this one even either. So have a look at. Now we have these results, what s equals to r theta. So omega is equals to theta over t. So theta, you can get theta from this one. Theta is equals to omega t. Now go back to there. So that's why I always stress about angular velocity and angular motion, circular motion and simple harmonic motion too much, because it's really essential. Now omega is equals to theta over t. So let me get this one. Theta is equals to omega t. Now I'm going to add this result to here. So my finalized equation is going to be x is equals to a sine omega t. This is one of the result. So sometimes you may find it with certain phase angle. I didn't teach you that thing so far, but it might be something like this. X equals to a sine of omega t is the angle. So it might start with some other point. That's the simple thing. If you go back to the previous page, so in this one, if you have any starting point rather than the vertical axis, you start at a certain angle of pi already, and you make the new angle theta from there. That is what it is. Now this angle is nothing other than theta plus pi. Okay, that's the thing. So it's not a very big deal. It's really simple thing. So I will teach you what is phase angle later. Now have a good look at. Now you can add this angle as pi. So that's really simple. Okay, now in this one, put answers for the following questions according to the equation given below. And it is like x is equals to 0.05 sine 2 pi t plus pi over 3. So I just told you how to solve in the previous one. So in this one, what is the model? So you write, I'm just going to back to our previous knowledge. A is equals to omega squared x. We have to compare everything with this equation to find out all the answers for this set. So I left 2 questions for you to practice. It's the same similar way. Now I have to compare the equation with the non-equation. What is the non-equation? It is the displacement equation. We have only one equation, that x equals to a sine what? Omega t plus pi. Okay, so have a good look at this is x, this is a, sine is sine, so 2 pi is resemblance to omega in this case, and the t is t, and this whole pi over 3 is the what? Starting angle or initial angle, initial position, phase angle. So however x, so this one is asked the amplitude. Amplitude is resemblance to this one. What is it? You can obtain it directly from the equation 0, 5. Okay, so we don't know any unit, so just leave it, and any certain unit. And the frequency, how to find out the frequency? So you know the omega is equal to 2 pi. So your equation is the frequency equation. I told you to use this equation directly, 2 pi f. If you have forgotten, just go back, and I just show you the way how to obtain it. See, that's why it's really essential. Omega is equal to 2 pi f. You may use this one and obtain the result. F is equals to omega over 2 pi. So omega is equals to 2 pi over 2 pi, and 2 pi and 2 pi cancels off each other. So frequency is going to be what? Nothing other than 1 hertz or s minus 1, whatever you can write. Now the periodic time, in the same way, you may remember this one. We obtained the equation, this one. So it's omega is equals to 2 pi over t. I show you how to obtain it. It's really ugly here, so wait. So omega is t is equals to 2 pi over omega. So you may write it. It's really simple. Here. Now you may just write the equation. T is equals to 2 pi over omega. So what is 2 pi? Is 2 pi itself, and omega is going to be, what was omega? 2 pi again. 2 pi, and the periodic time is 1 second. That's it. Now, or you may obtain this one from the previous answer. I always strongly say don't use the existing answers if you have made a one mistake. So you may repeat the same mistake over here. It's like this: 1 over f is equals to 1 over t. Yeah, if you just substitute this wrongly. So imagine if you get something by mistake, by mathematical error, something by mistake, somehow you got like 2, then you get the answer like 0.5. No? So if you get 2 different answers, so it's going to be a chaotic. So don't apply if you have no other option. So you can get the periodic time in this manner as well. It is 1 second. So but I'm telling you, don't use. So starting angle, phase angle, what is it? This one, this whole set. So starting phase angle is equals to nothing other than pi over 3. Really simple calculation. Now next one, let me explain you the two sets of equations in simple harmonic motion given below. First set is y 10 sine pi over 4 and 12t and plus 1. So let me write the equation again. Y1 is equals to 10 sine pi over 4. Okay, now 12t plus 1. Okay, now it is going to be a bit different. Now you know the equation you have to compare. What is it? X equals to a sine omega t plus pi. You can't use it because it is, you have to solve it now. Okay, you have to solve it. The other one, let me get the other one as well. Y2 is equals to 5 sine 3 pi t plus pi over 4. Okay guys, now there is a bit different here, because in this one, so may have a good look at. So this one, in this sense, saying m is the ratio between amplitude. Let's find. So the ratio is like 10 is to 5. That means 2 is to 1 is the ratio. Okay, 2 is to 1 is the ratio. And in the next one, the ratio versus ratio, no? So ratio between amplitude is m. So let's find the ratio between the other one. So now you have to find out the periodic time. To find out the periodic time, you have to do some simple and essential thingy. What is it? You have to find out the omega thing. But this one is really weird because why there is a certain thing. So now what to do? You have to open up the bracket. So once you open it up, so it is going to be 1, so 10 sine. Now just put it there, and inside it becomes, it's like pi over 4 times 12t plus 1 times pi over 4. You may see something really interesting, and let me drag this a bit down. So that's it now. Let me drag this down a bit. Okay, now you have to just open this up. So y1, what is y1? Y1 is going to be 10 sine. Okay, now solve it 3. In the bracket you can write it like 3 pi t plus pi over 4. So the latter half is the same. Here these two have no difference. Now omega thing is same. If the omega thing is same, so the periodic time thingy is going to be same. N equals to 3, the same thing, similar thing means the ratio is going to be 1. So you are now comparing m is to n. M is what? 2 over 1 is to 1. That means you just not comparing anything. So the result is going to be 2 is to 1 itself. The answer is this, nothing other than that. Okay, that's how to obtain you to compare. When you find something like this, you have to open up the bracket and solve. That's one of the thing. And ratio, so the amplitude you can directly obtain from the equation. Now next one is not that complicated. It's a really simple one. And a variation of displacement xm of a particle varying with time t is given by the equation x is equal to 2 cos 0.5 pi t plus pi over 3. What is the maximum acceleration of the particle? Okay, what is the maximum acceleration? Let me just find out one really important result from this one. X equal to 2 cos 0.5 pi t plus pi over 3. Okay, I told you there's a sine cycle as well. The equation is like y is equals to a cos omega t plus pi, nothing else. So it is like 0.5 pi. It's like 0.5 pi. So this omega is equal to 0.5 pi. We know that omega is equals to 0.5 pi. Leave it. This is not the answer. So now I want to find out the maximum acceleration. Your equation, what is the acceleration equation? I told you to remember the characteristic equation. This one, a is equals to omega squared x. What is the maximum x you can obtain? The maximum x is nothing other than the amplitude. That gives you a max is equals to minus omega square x. Really simple, isn't it? Sorry, wait. A, this is the maximum acceleration. So you may get it like a is equals to minus omega squared x. That is the maximum x is a. So a is equals to minus omega squared a. So finally my omega squared thing is this one. So omega is equals to 0.5 pi square, and a is what? 2. It is 2. You may write it like this way. 0.5 is what? 1 over 4, 1 over 2 pi when you square it, and time 2. So your answer is going to be a max is going to be, now it's going to be 4. So 1 over 4 pi square times 2. Now 2 and 4 cancels off. So a max is going to be pi square over 2. Answer is this exact particular one. Really simple, isn't that? So I'm going to make the next video. What is my next aim is to get this one. Now I'm going to add one page. Next mission. What is next mission? It is all about to obtain this cycle thingy with the various velocity variation of velocity from point to point. So you know that it's just start from here with zero velocity and increase to max and comes back. So that thing, so how to get it? So you will get certain equations like this. uh, uh sorry, omega a square minus x square, this equation, and some applications of this one and many other applications. This one has a vast range of applications. So I am going to give you that theory part, and the very next after that, very next after this one is going to be calculations. So after that, so the simple pendulum and so on. So get ready for these two videos really sooner. God bless you guys.